Welcome to Introduction to Data Visualization. I'm Francesca Albrezzi. And again, I'm going to put these slides up while everyone is getting settled, if you wouldn't mind to go to these links and take the 2 quick surveys. That would be great. You can also find today's slides at the top link right there. And the other 2 links, one is for a sign-in, so I know who attended, and the other is part of a mystery survey, which will be part of our workshop later on. So definitely fill that out. Again, it should take very little time. So while you're doing that, I'm going to introduce myself. So I'm a digital research consultant for the Institute for Digital Research and Education. I also lecture in the Digital Humanities program and in the World Arts and Cultures department. My background is in art history. I've worked in and with museums for over a decade at the GRI, the Getty Research Institute, the Smithsonian, Los Angeles County Museum of Art. My dissertation looked at the immersive technologies in museums and cultural heritage, how they're being used there, thinking specifically about forms of publication, display, and information capture and transmission. So that's a little bit about my background. But I also have been working in digital humanities, like I said, for a really long time. So data and visualizing data is very important to what I do and what I love to teach. So I'm letting a few others in to join us. And if you're just joining us now, please take a look at these surveys, fill those out really fast, and I'm sending you a link to the slides for today in the chat. So as we sort of get settled in, keep a lookout, I just want to say, for a Coding for Creatives workshop from me in November, and for more XR or extended reality workshops that I'll be teaching in the winter and spring. And if you have any questions or interest in learning a particular skill in extended reality, let me know. Immersive technologies are sort of my main thing as we're trying to build out our resources in that area. So I'd love to hear from any of you who are interested. And so please, someone is asking in the chat to add the links in the chat for the surveys. I'd have to pop out to do that, but if you go into the slide deck, you can get the links right in the slide deck. So you can help yourself there. All right, so I'm going to go ahead and move forward and go over our agenda for today. So today, what we'll be covering is what is data visualization, first and foremost. We'll also get familiar with different kinds of data and methods for visualizing. We'll cover best practices for data visualization, and then we'll look at 3 tools for data visualization. So first is OpenRefine, which used to be Google Refine, and is a free open source tool that helps with data cleaning. So before you visualize your data, you want to make sure that you have clean, standardized data. So we'll look into that. Then we'll also work with Google pivot tables as a bit of an appetizer, and then we'll get into Tableau, which will be our main course for today. So if you have any questions, again, for those just joining, you can follow along with this presentation at the link in the chat. So data visualizations are everywhere today. We see it in news, medicine, politics, sports. They play a vital role in how we communicate and understand what is happening in the world around us. More specifically, for scholarship, they can be a vital method contributing both to the process and product of research. So Hans Gosling's Gapminder project, data visualization project, is a great example, which you can see here. I won't play the video now because I know videos over Zoom can be a little stop and start at times, but if you want to take a look at that at your own leisure, I highly recommend it. But it's a great example of how we can create strong academic arguments with data visualizations. He plotted health data from all over the world and animated it so we could see the change over time. This bird's eye view really shifted the narrative in regards to developing, quote unquote, countries and what their health situations were like. So to make a data visualization, you need three things, right? Data, format for data viz, and a tool that can produce that format. So it's the intersection of these three things. And to pick the best visualization type for your data, you need to understand what kind of data you have. Here are a few examples of the kind of data people want to visualize typically. So there's temporal data. So this is time-based data where the goal is to understand changes over time. Things like survey data can help us get an overview based on clear boundaries set by the PIs of the study. There's computational data, right? Usually these are big data sets that involve mathematical equations to produce. There's community-based, so census or demographics, we see that a lot. Social media, combing platforms like Twitter and using indexes or hashtags to identify particular information. Archival data, this is what I'm most familiar with. Usually collections data has a lot of metadata attached to it, so old manuscripts, photographs, things like that found in special collections. But maybe we can just take a second as a way of getting to know one another and what everybody's working on. If you wouldn't mind sharing in the chat what kinds of data you're working with, or what other kinds of data outside of this that you're interested in. So I'll give everyone a second to just go ahead and put that in the chat. Yeah, so Catherine shared that she's working with lots of social media data. Lots of people working with social media data. Computational, archival, great. Medical records, absolutely. Biodiversity data surveys, sure. All of these are wonderful, and these are exactly the type of things that we're talking about here, right? And it's really important to be able to showcase these things in a way that we can communicate a lot about this data in a single image. So that's where the power of data visualization comes in. So it's important for us to understand a little bit about the kind of data we have in order to know how best to represent it visually. I'm not a statistician, but these basics are very helpful to know, and I hope any people in statistics in the room will feel free to correct me if I'm getting anything wrong or confused, help me clarify things if need be. But in statistics, nominal data, also known as nominal scale, is a type of data that is used to label variables without providing any quantitative value. It is the simplest form of a scale measure. Unlike ordinal data, which we'll talk about in a minute, nominal data cannot be ordered and cannot be measured. So here are some examples, things like hair color or different kinds of instruments, right? Those don't have a value per se, but they are things that we can describe. They're categories. Ordinal data are the type of data in which the data values follow a natural order or progression. So one of the most notable features of ordinal data is that the difference between the data values cannot be determined or are meaningless. Generally, the data categories lack the width representing the equal increments of the underlying attribute. So I teach DH 101 on occasion, Digital Humanities, Introduction to Digital Humanities. And so this example pertains to that. So if we're giving an example of ordinal data, it'll be these types of categories, right? A lot, super duper, a lot, so much. I'm crying right now thinking about how much I love digital humanities. Well, all of these things don't have a specific measurement in between them. We just understand intuitively the difference between them. And this will become clearer when we talk about the next thing, which is interval. So interval data, also called integer, is defined as a data type which is measured along a scale in which each point is placed at equal distance from one another. So interval data doesn't have a defined absolute 0 point, which is present in ratio data, which we'll talk about in a second. The lack of absolute 0 makes comparisons of direct magnitudes impossible. So for example, object A is twice as large as object B is not really possible in interval data. And with ratio, which is our final kind of data that we're going to talk about today, there is a known, consistent, quantifiable distance between each of the variables, and 0 really means 0. So for example, you can't have a partial bird spotted. You spot one bird or two birds or three birds, right? And in any relation to each other, we can view these kinds of data like stepping stones, getting more specific and ordered as we go along. And I think this chart makes that really clear, right? We move from nominal to ordinal all the way to ratio, each time getting a little more ordered and a little more specific. So what does it mean to take these various types of data and visualize it? What actually is information visualization? Well, my answer, what I like to say, is that it's a mapping between discrete data and a visual representation. More broadly, in terms of scholarship, data visualization is a method like many others. So methods and methodologies vary within disciplines due to overall research objectives. And you can see from these examples here, if you look at science compared to social science and versus humanities, some of these things overlap, and then some of these things vary quite widely. And as a result, so will the process and product of our visualizations. So for example, the type of data viz you will choose to use will depend on what type of data you are working with and the goals for what you want to communicate about that data. So as someone who comes out of museums, if I'm thinking about a digital exhibit, right, I'm going to be very focused on images. For text analysis, we might be looking at trends and wanting to see how often a word is used. Things like digital editions are going to be really focused on how text is displayed for a reader. Timelines, really hard to showcase a large amount of time on a limited screen space. So the functionality there of how you do that really matters. And so on and so forth. You can see here. Are there any others that people don't see on this list? I'm always curious if there's other types of data viz that people are working on, perhaps things like word cloud. Maybe you want to put in the chat or unmute yourself and share. That's okay. If something comes to you, feel free to share it in the chat. But today we're really going to be focusing on charts, graphs, and plots. So some of the most common data visualizations are graphs, which in one of the types of data vizzes today, which is one of the types of data vizzes we'll be making today, and they form a subgroup of charts. So graphs specifically present mathematical relationships in data sets. In other words, graphs make pictures of numerical information. Graphs can be simple and they can be quite complicated, but they should always be selected to present their data as clearly as possible. So keep in mind that sometimes two graphs are better than one if each graph shows a different aspect of the same data set. Plots are another type of data viz, and they're different than graphs in a few key ways. So we make plots out of points, and for something to be a plot, both axes must be continuous. For example, you can make a plot of the height versus weight of a population, but not the height versus the species, because species are discrete. So you can't plot a point halfway between a cow and a chicken, right? Does that make sense? So I'd say that plots are a subset of charts and graphs. So now that we sort of have that basis, I want us to think a little bit about why do we visualize and why is visualization so popular now before we jump into doing some visualizations ourselves. We tend to think that information graphics have some special access to the truth and that they simply present fact. And since we're in the middle of an upcoming election, and I hope everybody is registered to vote, and if you haven't done so already, so quick plug on that. It's a great right that we have, and we should all do it if we're able. So this is an example of another billionaire that was running for office in 1992. This is Ross Perot, for some of you who may remember. Many of you were probably not even born. But for example, this is one of several of his infomercials that ran during the 1992 general election campaign. And he was known for these charts that he would use. And what stands out in his presentation, I won't play it for you now. Again, I'll let you enjoy that on your own. But what stands out about his presentation and his use of these charts and graphs is that these numbers seem definite, right? They seem to be, he seems to be an authority on all these subjects, and he has a certain command of the facts. But compare these two graphs and tell me what you see, or just take a moment and look at these two graphs. Does anybody catch what the difference is here? You can either type in the chat or unmute yourself. Yeah, so Ruben, Tony, yes, everyone's noting scale. Scale affects drastically how we interpret this information. So, for instance, in this one, what's confusing or problematic here? Well, we're topping out at 42%, which is a fairly arbitrary number for a stopping point, at least. Percents are normally out of 100, right? So 42% is kind of a strange point to cut us off. Even if this was simply zoomed in to help us physically read the chart better, the result is that it looks like a drastic change. The other thing to note is that the use of now in the labeling is not very helpful, right? We're not really sure what the time difference is between January 1st, 2013 and whatever now is. So labeling is critical in understanding information visualizations, and we want to be as specific as possible and avoid labels like now or before and after. So this one I threw in case anyone saw the LA Dodgers come back on Sunday. That was a big win. So this is a baseball example. The only, what we're seeing in this one is only showing us a 2-year span, which is a very limited window, and you want to avoid that. We can't really know without additional context if this is such a drastic dip in performance as it appears here. Unless you're really familiar with baseball and this particular player, you need more context to understand the significance. And a visualization is not just about the graphics. Like I've pointed out in these past couple of slides, labels and titles are really important to pay attention to. So cumulative, as you see at the top here, can shift a line graph quite drastically and obfuscate what might be the more useful information depending on what your research objectives are. So this tactic is fairly commonplace, particularly in business. So when you're reading and creating data visualizations, it's important to be clear on what is being communicated and why. And just to show you the difference here, without the use of the cumulative approach or adding together of the numbers over the years, the graph actually looks like this. That steep slope is showing us the growth of all-time sales. So past years and present numbers added together. That looks very different from the quarterly sales that are happening in this version. And this is the difference between looking at something from a sweeping overview position versus a more granular perspective. And I'm not putting a value on either one of these things. It just depends on what you're trying to communicate to your audience. So these contexts become critically important when your data will be, or how your data will be read and understood. And then just finally, to wrap this up before we get into our own hands-on portion, there's the simple matter of getting your figures right. So you'd be amazed at how many times people just forget to sort of proofread things as you would a paper that you turned in for a class. You want to have people check your numbers and make sure that everything's adding up correctly. This is a little blurry, but I think we can all see that a pie chart has to add up to 100%. So obviously these percentages are off. And then remain always on the lookout for more dubious stuff. I'll give people a second to take this in. Can anyone tell what's going on here? Yeah, 721 is higher than 873. It feels upside down. Exactly. So they've switched what's common practice, which is to put the 0 down on the bottom in the left corner, and they've put it at the top on the right, so it flips the graph. So best or common practices can be used against a less keen observer, and we have standardized visualizations enough that we hold certain assumptions about how they usually operate. So these things are 0 goes at the bottom, not at the top. We read from right to left, typically. People may manipulate these elements to suit their outcome, so we want to keep an eye out for them. A good data viz reader will always be checking these details and following common and best practices to ensure a graph is read correctly with as little effort as possible. So what I hope these problematic data visualizations highlight is that there is a tension between design and data when representing data visually. And we don't always agree what makes a good visualization. This is a fairly recent article that covers that debate, so I recommend taking a look at it. In it, the author describes that designers often feel it's important to make sure the graph grabs and holds your attention and is intuitive to navigate. Statisticians or data scientists, on the other hand, want data visualizations to clearly communicate the data. But beauty and accuracy don't have to be at odds. And I hope that's part of what you take away from today's workshop. What we saw in those problematic data visualizations is how both design and sometimes numbers can fail us. So let's start first with some of the design elements that are critical in making data visualizations. So we've seen from some of these bad data visualizations, certain design elements that can be very crucial in data visualization. And the first and foremost of that is position. When we talk about position, we tend to be looking for things like upward or downward trends, clusters, or if there are any outliers. If you remember from the first comparative graph I showed, changing the scale shifted the appearance of the graph's bars. So the distance between, or length, was further emphasized, and we tend to interpret that as significant. The greater the distance, the more significance we assign to the difference. Angle is very useful in communicating a part in relationship to a whole. So when you're thinking about trying to show the percentage of something, angles are really good for that. But we should keep in mind that pie charts are notoriously hated within the data viz community, and we usually are usually thought to be illegible after about 5 slices. So keep that in mind before choosing to make a pie chart. Even though bar charts are boring, they can communicate much more clearly than a pie chart with too many slices. And most data visualizations are read from, like I said, left to right and down to up. So shapes can be extremely useful in representing different types of data. They catch the eye and signal difference really quickly to the viewer. And likewise, area and volume help us compare if something is larger or smaller at a glance. And finally, color can demonstrate range really well. But in terms of accessibility, we have to keep in mind color blindness. So avoiding reds and picking a spectrum that is high contrast is really important. So what are we best at interpreting? Well, like I said, we're better at interpreting some of these things than others. If you see those things to the left of center are what we're better at interpreting. So position is something that we're really good at interpreting. Whereas saturation and hue, we're less good at interpreting. And here's what happens when we put the approaches together from a designer's, from both a designer's and statistician's point of view, right? Position, no matter what, is going to be critical, but when you're working with something like nominal and ordinal data, those sort of differences that are highlighted in the type of data are you want to accentuate those things through things like color and hue, even though those things are harder to read by the eye, they help communicate more quickly that level of difference. Whereas in interval and ratio, things like length and direction become increasingly important. Does that make sense to everybody? I'm going to sort of wrap this portion up as we head into our hands-on, but please let me know if I'm going too fast. I just want to sort of get everyone on the same page here on how we combined both design and data together. And when we think about the process, it often looks something like this. So we come up with a general question or set of questions for our data, and then we often explore the data visually. This is an iterative thing. You don't sort of put your data into a data tool and come out with a visualization and that's your final product right away. It's often an exploratory process. And so you may see something in those first visualizations that will cause you to go back and revise your question and maybe even revise your data. Maybe there's a certain area of the data that you need to find out an additional data type to help support it to visualize it properly. So you'll want to go back in and create various data sets or versions of your data set to visualize it. And you visualize it again, and you might go back and do it again. So it's iterative. It's cyclical in that way. But the 3 basic principles I want us to remember as we get into using tools is that to make strong data sets, we need to keep things simple, carefully label, and explain where your data come from. comes from. If you do those three things, you're always going to have a fairly strong data visualization. Okay, so as I was saying, all good data visualizations start by cleaning and standardizing your data. So how you organize and label your data matters. It matters a great deal. The terms you use matter. Each field or discipline in academia has its own standards. So you always have to do some research on that when you're getting started. But I wanted to show these examples. So for example, in the Library of Congress, it has its own list of authority terms for subject headings. And those are the words that you use when you go to look up a book by subject matter. So that's one example. But these examples here, and what I'm going to show you today is how you can use another authority known as the Getty thesauri or the Getty Vocabularies with a tool called Open Refine to help you clean and standardize your data. And this is really great for cultural artifacts, but you'll find these types of things in all types of disciplines. There's always going to be those who have metadata standards in your field, so you'll want to research that. That being said, these two resources are freely available, and they're great introductory resources that anyone can use. You can probably get through them in about a day or so. They're quick reads, but they're really great for understanding best practices around structuring and standardizing your data. So one is Introduction to Controlled Vocabularies, and the other is Introduction to Metadata. They're both freely available online, so definitely check those out. So with that, we're going to jump into our tutorial portion. If you haven't had a chance to, we're going to download some software if you need to do that, but there are many different ways to clean and standardize your data. Excel and Google have some things built in, but I want to recommend Open Refine, which is free and open source, like I said before. It can help you do transformations on data in a few clicks, and it's very powerful in that sense, especially if you're working with large data sets. There's a bit of a learning curve, so we'll just familiarize ourselves with some of the basic functions and then do a test on how we can pull from an authority source to do some more powerful stuff. But again, this is more of a visualization workshop than a data cleaning workshop, but I just wanted to sort of expose everyone to this so you know what's out there. So if you didn't get a chance to beforehand, or if you didn't see my email I sent out in advance of the workshop, please feel free now to go to openrefine.org and download the software. So I'm giving everyone a second to do that. Once you're there, you'll select the download option from the left column and choose a version for either Windows, Mac, or Linux, depending on your operating system. And for this demonstration, I'm using the latest Mac kit, which is version 3.4.1. And just a side note while you're doing that, for each project, all users should always use the same version of Open Refine. For example, if two people are editing a project using Open Refine, one person should not use version 3.2. If the other person is using version 3.3, that's going to cause you some issues. So you want to make sure that you're always using the same type or same version of Open Refine, especially when you're switching or working on a shared project together and sharing files. So download from there. And this is just a side note. There may be a security pop-up when you encounter that you encounter on Mac OS, since it's a public software. You'll have to go into your security and privacy settings on your machine to enable it. So select the question mark icon in the warning message to be directed to instructions on how you can allow the software through your security settings. And once you've done that, double click on the icon to open the application. Does anyone need a second more to download things? Are people feeling like they've got a good handle on that? Yeah? Okay, great. So once the app opens in your browser, you should see something like this. And just to note, it works best on Google Chrome, so make sure to open the app before trying to open your files. If a tab does not automatically open in your browser when you open the app, you can also enter this link, or I'll show in another slide an alternative, but it's a browser-based application, so you're going to see it in your web browser. So let's add some data. The Tate Museum in London has put much of their collections data online, which is great. So we're going to use that for today. And you can get to that data by going to bit.ly/Tate Artist Data F2020. And that will allow you to download the spreadsheet. So once you're there, you'll be able to go to File and then Download, and you want to download it as a CSV file. Is everybody able to do that? We should say, is anybody not able to do that? Everybody's good? Okay. So while you're doing that, just in case, I'm going to run through some quick basics of OpenRefine before we jump into the tutorial on how to reconcile parts of your data using the Getty vocabularies. But this is just sort of a whiz through of the functionality that's available in OpenRefine, so you can start to envision how you might use it for your own projects. So you'll start by creating a project and inputting your data like most other programs. You will do this together with we'll do this together with our data in a minute, so you don't have to do it right now. But if you ever have trouble launching your program, like I said, you can always type in localhost :3333 in your browser and the program should open if you have it downloaded. And what Google Refine or OpenRefine is great for is that it allows you to facet and filter your data quite quickly. This is an example. You can use a cluster function and review and organize your data and apply changes to a large set of data types really quickly. You can trim any extra, so removing white space is always a great place to start when you're cleaning up data sets. If you've got a new data sheet, the first thing I would tell you to do is make sure that you've removed leading and trailing white space, and that's really easy with OpenRefine. As you can see, you select on these drop-down arrows, you edit slides, or edit cells, common transformation, and you just trim leading and trailing white space. That's how easy it is. You can also find the biggest group quite quickly. So this is, again, great for getting to know your data and what's there. You can switch from name to count to find the biggest and smallest groups. And you can batch edit like records. So if you find things that are similar, OpenRefine groups these things together for you so that you can assess them, and if you would like to merge those things so that all your terms are the same, you can do that really quickly. You can also, like you can do in Excel or Google Sheets, you can split columns into separate info. And you can use custom separators to do that. And like Excel and Google Sheets, you can make mistakes. There is an undo redo function, but I believe this is still the case that you have to be in Chrome to use this feature. So you want to keep an eye out for that. And when you're working with numbers, you'll use the numeric facet. We'll talk about this a little bit more when we get into Tableau. But most visualization programs are going to require you to tell them what data type you're using. And so if you do this with Open Refine, it saves you a step later on when you move your data into a visualization tool. And then getting into the more advanced sort of things, you can use expressions to focus on specific areas of your data. And again, like I said, this is just a sort of drive-by of the functionality of Open Refine. We'll actually get to do something in a minute with it. But the point being is that there's a lot of resources out there. These are some that I've helped put together with Miriam Posner, who's in the Information Studies department and also teaches in the Digital Humanities program. Her resources are phenomenal, so I highly recommend if you want step-by-step on how to do any of the things that I just showcased in terms of functionality, these resources will show you how to do that. And I'm happy to meet with anyone also outside if you're interested in learning how to do these things. So for what we're about to do, I'm pulling from a Getty Vocabularies Open Refine tutorial, and it also has tips for advanced users. So I'm giving you that full link to that documentation in case you want to check it out yourself. And I'm also providing you with a couple other links here. And what I'm about to show you is based on like I said, an Open Refine tutorial by the Getty, which will allow you to reconcile your data with their linked open data to help you standardize your data much more quickly. A reconciliation service is a web service that, given some text, which is a name or a label for something, and optionally some additional details as well, returns a ranked list of potential entities matching the criteria. So the candidate text does not have to match each entity's official name perfectly, and that's the whole point of reconciliation, to get from ambiguous text name to a precise identifier entity. For instance, given the text apple, a reconciliation service probably should return the fruit apple, the Apple Incorporated Company, and New York City, right, which is also known as the Big Apple. Using the API, you can do this for a variety of data services. For example, the last link in this list is for how to reconcile data with Wikidata and VIAF services, which is for libraries. So there's going to be a lot of different types of authority data files that you can use as part of this. But I'm going to show you how to do it for the Getty Vocabularies. And the Getty Vocabularies include the Art and Architecture Thesaurus, or the AAT, the Getty Thesaurus for Geographic Names, TGN, the Cultural Objects Name Authority, or CONA, the Union List of Artist Names, which is what we'll be using today with our Tate dataset, and the Getty Iconography Authority, or IA. And the three most popular are available in Open Refine, where you can reconcile your data based on these elements here on the right. So if you see this list on the right-hand side over here, these are the types of things that you can, the characteristics you can reconcile in Open Refine. So we're going to do this for our list of Tate artists to make sure we have their make sure that we have their ULAN authority file attached to our data. But you could also do this with TGN, not TNG, that's Star Trek, but that would be cool, and get their location data, right? So if you use the thesaurus for geographic names, you could get the lat-long coordinates for places, which is actually a really great thing to know how to do because many GIS programs, this is part of their paid services, is to provide you with lat-longs, and you can get them for free through the source of geographic names. So that's one thing to keep in mind. So if you all have your Open Refine open, you're going to want to go to Create Project. And under this computer, you're going to choose a file. And you're going to choose that Tate Artist data sheet that you downloaded. And you're going to import that spreadsheet so that we can edit it. Alternatively, you may choose to open a project or import a project to continue work on an in-process project. And obviously, you can see here from the choices at the top, you have a lot of different data types that you can use in Open Refine, or different file types, I should say. And once your file is uploaded, click Next. Let's give everyone a second to do that. So once the file is uploaded, you will see a preview window that looks like this. Does anybody not see that preview window? Please let me know in the chat or unmute yourself and let me know. Oh, everyone's following along? Okay, great. So give your project a name in the project name field or use the default name. So that's right here. Select Create Project at the upper right of the page. You can keep all these settings. These are all fine. This is how the data is getting parsed. That should all be automatic, and you can just click Create Project. You'll be taken to another page from which you can edit this, the cells and columns on the spreadsheet and use the reconciliation service. So we'll do that in just a second. So this may take a minute to do. Depending on how large your data set is, it may take a few seconds, if not a little longer. Is anybody having trouble getting their data into Open Refine, or is everyone okay with that? No? No issues? Okay. So when it's done loading, you should see something like this. At the top, you will see the number of rows, which is 3,532 in your sheet, and you can adjust how many are displayed, but Open Refine doesn't show you all of your rows at once, like in Excel or Google Sheets, and this is because you're really meant to be using it to clean your data. So you're going to be performing things in batch more than you are on individual rows. You can work with individual rows, but it's really designed for doing sort of batch transformations, big transformations within your data. So to reconcile, you're going to go to the name column and click the down arrow on the left. You're going to select Reconcile and then select Start Reconciling. Now, the reason why I've canned all of this is because reconciling can take a really long time. And in fact, well, I'll walk you through this process here, but once we hit start reconciling, it will take about an hour to an hour and a half for this data set. So if you have even bigger data sets, you're going to want to factor that in. You're going to want to be able to like go have a cup of coffee with somebody, or remote cup of coffee via Zoom, since we aren't getting together all that often anymore. But you'll want to take a break and come back. And that'll keep going in your browser, and you'll see it ticking away in your browser. So you will be able to track the progress and know that it's still working, but it does take a little while. So from the page, listing services, select the add standard service at the bottom left of the page. And this is how we're going to, I don't know if you can, my bar came up in front of my slide, but you can, in that bottom left corner, you'll see add standard service. And this is how we're going to add the Getty vocabularies. So to connect the Getty vocabularies, you're going to input this URL. So http://services.getty.edu/vocab/reconcile. And once you've done that, you're going to select add service. And it's as easy as that. The Getty vocabulary service will now appear in your service list, and every time hereafter that you use this same version of Open Refine on this computer, the Getty vocabulary service will be on your list. Was everybody able to do that? Or anybody not able to do that? Still with me? Okay. So in the service list now, click the Getty Vocabularies Reconciliation service and select one of the vocabularies. In this case, we're going to use ULAN. And we're going to use auto matching if there's a good correspondence between your source data and the set in the target Getty vocabulary. You may wish to use auto match candidates with high confidence, which is in the lower left corner. You may want to turn that on. In this case, we do, because ULAN does match up really well with this Tate data set. So we can leave that on. But auto match tends to work better for ULAN than the art and architecture thesaurus or the thesaurus for geographic names, due to the typical variables, so properties in the source detail. In most cases, you will have better results in matching if, in addition to matching on the name or term, you can compare properties in the source data to properties in the Getty vocabularies. If your data set contains columns that can help identify or qualify the entities during the reconciliation, Open Refine reconciliation results will take these columns into account in the matching scores. So for example, if for ULAN we have the birth and death date, we can add, because we have similar columns or data types in our data sheet, right? You can input the property selections under the column as property. So you can see here for ULAN, we can actually type in, we have in our own data set year of birth, and we know from that properties list that I showed you several slides back that birthplace is one thing that ULAN has. So you can match those things, and that'll help you make those matches more confidently. So if you just start typing a value, you can autofill by choosing sections provided for ULAN. Make sure you also select the include box so it knows to use those fields. So this include box here, I want to make sure that you do that as well, right? As you go through. And when you finish adding properties, you'll click Start Reconciling, and you'll be taken back to the spreadsheet view where progress is tracked. And like I said, this will take some time for this sheet. It took about an hour, hour and a half. So I'm going to show you the next part so you know what to expect. And you can see it over here. I actually have my Open Refine data sheet open here. So this is an example of what happens when I've used it for the artist names. And so, for example, I've gotten a match here for Bernice Abbott, and I can actually click on this and it'll take me to the Getty record. So I can check the Getty record if I need more information. Bring this down for a second. The Zoom bar got in the way. So when you finish adding properties, oh, yes. So let me move to the next slide. I'm sorry.
Okay. Do we want to check include for all of them or just the ones that we
just
put, like,
yes, great question. Just the ones that you're able to match within your columns. So that would be, in this case, birth date or birth year and death year. You can also do, which I'll show in a minute in these slides, place of death and place of birth, if you have that information, which we do as well. So after the reconciliation process ends, you'll want to verify these matches, and you may wish to check these matches by hand if possible, particularly if the ranking is 40 or lower. The possible matches in this example to Yulin appear in the column in the blue under the source value being matched, which is the name of the artist that we had originally, and sorted by ranking in parentheses. So these things right here, this will let you know sort of the percentage, how likely of a match it is. So obviously this first one is a pretty good match. It's above 40. So we know that that's the likely candidate. Same here. All these lower numbers are indicating that it's not as likely of a match. And this one's a 50%. So we know that's likely going to be a solid match compared to the information that we have in the other columns as well. But just a note on the scoring, the Vocabularies reconciliation service for Open Refine does not use normalized scaling for matching results. The search gives relative results based on how many data points match Vocabularies data. So text matching, broader context, birth and death dates, things like that. So the things that we've included. In general, the better matches have higher scores, and it's up to the user to determine what the acceptable threshold is for an actual match. In the same manner, the service intentionally does not do auto matching because they don't want to assume any kind of expertise about the source data and create bad matches. So for example, if you're working with a special collections, a new set of data that you formed based on special collections material, maybe you have a date that precedes the date that they have in Yulin, and that's actually an important research find, right? That's not something that you're going to want to erase and overwrite. You're going to want to see and acknowledge that. So that's why when I talk about data cleaning being a part of your process and this being an iterative process for data visualization, these are exactly the types of things that you're going to run into that are going to help your research process and help your discoveries happen. You can see information from the Yulin match by hovering over the blue name. Hovering in versions 3.2 and higher works. If you have 3.1, you must click the ULAN record to actually see that information. But I think all of us should be on 3.2 or higher at this point. When a window will display the ULAN data, then you can click from there, and you can choose if you want to make a match based on the birth and death dates that are there as well. And you can match this cell, so this particular item. But if you have multiple values in this column that should be reconciled to the same vocabulary record, you could click match all identical cells. So those are things like the birth and death year, right? So if you wanted to change and transform it across that record, you could, based on the information that's coming from ULAND. I'd advise that you use this option with caution, given the high probability for homographs in the vocabulary data, but also perhaps you've formed your own data, like I was just saying, and your sources provided an alternative set of dates, and you want to compare this to the authority file as part of your research. So if you need more information before deciding, you can, like I said, always left click on the blue name and go to the full web record to see the Getty vocabulary entry. And so this is, it may take a second once you've clicked match, but once you do, you'll see it's given you, this is how a match will display. And then I've shown you how to do an example from ULAND, and the reconciliation service also works in the same way for AAT and TGN matching. I just want to point out, though, that in reconciling using the thesaurus for geographic names, several homographs have nearly equal ranking. So you can left click to go to the full records online in order to see if the geographic coordinates and other information can help you assist in making that decision. So because these things are all in the same column, you can see here, most of these things are coming out. It's not quite sure which one to choose. And this is probably because we have city and country in the same field. So I'm just going to quickly go over here and show you on the fly how to do this if you wanted to separate. So I had already separated these things here, but let's move to place of death, and I can show you again how to do that. So if you go to place of death, you can click to edit column and split into several columns. And we want to use a comma, right? That's how they're separating the difference between country and, I think in most cases, cities. So we'll say okay, and then Open Refine will do its thing. And now we have additional columns. So we have place of death 1, place of death 2, and we can run the reconciliation services on these things independently to get slightly more accurate connections with the source of geographic names. Does anybody have any questions on that? Okay. So we'll leave it there and move on to visualizing our data, but I wanted you to know what tools are out there to help you get a handle on your data, because it needs to be organized and cleaned before you can create strong visualizations. So definitely check out those other resources I included if you're looking to learn more. And I'm going to just pause for a second here because I saw a question come in the chat. Well, we have to go through every single row. So the way that in the advanced documentation, there are ways that you can do this transformation slightly more quickly. But the point is that they have made it more difficult, and they haven't made it automatic because they want you to look at every single record to verify that you're okay with that match. But in theory, anything over 40 should be a good match for you. So you can set up, I believe, an automation way that will automatically accept anything above 40 if that's what you want. But check out that advanced documentation for exactly how to do that. Okay, so let's jump into visualizations because I know we only have about an hour left and I want to make sure we get through actually visualizing data. So pivot tables in Google Sheets are going to be the first thing that we work on, and then we'll look at Tableau. But there are many tools for data visualization, and these are just a few that I'm noting here. Excel is great. If you have Excel and you're already working in Excel, there are many ways to visualize with Excel, but there's also things like raw.io. Microsoft Power BI has its own set of visualization tools. R, if you're in statistics, and R is becoming a really popular language, not just to work with data, but also to visualize it. And I, again, highly recommend taking a look at the workshops that Idri offers. There are always new ones coming out on different visualization tools, so definitely check those out. So we're going to quickly cover some basics of Google pivot tables and charts and demonstrate some easy ways to throw together useful data visualizations with lightweight tools. Think of this as your appetizer, like I said before. Getting into Tableau will be our main course. There's more of a learning curve with Tableau, and you can take Tableau a lot further if you're doing more complex data visualizations, as you'll start to see in a bit. But pivot tables are convenient and a great place to start and can get the job done pretty well. So what I want you to do is go to this bit.ly link for the responses from your mystery survey. So we're all going to be using a data set from that mysterious questionnaire, and you're going to make a copy. So if you didn't take that mysterious questionnaire, I hope you go back and quickly take it. I can see if we've got it right here. Let's see. Yes, we have answers. Yay, wonderful. So this is going to be what we use. I do have a sort of canned version that we can follow along here with. I may jump back and forth between these slides and doing the live demo, so bear with me on that. Also, the images in the slides are from another data sheet since I knew I wouldn't have your data until the workshop. So keep that in mind when you're looking back on the slide deck later on. But definitely go into that spreadsheet and make a copy. You don't want to use the same one that I'm using. You're going to make one for yourself. And so first we're going to select any column that isn't the name column. So if you want to go to department, we can go to department and select that column, and you're going to click on the chart feature. So for me, it's a little hidden down here. Sometimes you have to go to the ... the more to access. You're going to click insert chart. And automatically we have a chart. So you hit the chart icon on your toolbar when where the arrow is pointed, and voila, you have a chart by count. So you also have a chart editor to the right where you can customize the chart and change the chart type and the title and the color, all of that, etc. You also have a share, embed, or export your chart. In the upper right-hand corner of your chart, which is really easy to do. You just click on the 3 stacked dots in the upper right of your chart, and that should give you those options. So I'm going to, again, go back to my example here. So I'm seeing duplicate charts, which means someone didn't make a copy. So you want to make a copy of this sheet in your own Google so that we're not all making charts together in the same sheet. But the idea here is that, right, customize, if we go to customize, chart style, you can change this chart style, you can change it from pie slices, right, chart axes, all these things. Ultimately, we don't really want to use a pie chart, right, in these circumstances. So let's go back, see if we can't switch this up. And we want to switch the chart type to, it's a little bit clearer as a bar chart, right? And already we can see that since everyone entered in their information on their own and we didn't have any kind of data cleaning happening, we have a lot of different people here from various different departments, which is great. But point being, if I move this up for a second and scroll over, we can go to these 3 dots here on the corner, and you can edit the chart, delete the chart, download it. So if you want it as a PNG or a PDF, you can publish the chart, and publishing the chart will allow you to create an embed. So that's one way of being able to quickly share your chart out in various different forms or via link. Okay. So I'm going to go back to our slides. Did everyone log in? Was everybody able to get the copy? Yeah? Okay. Sorry, I was just seeing in the chat there was, yes, okay, great. Everybody got it working. Okay. So if you want to do something a little more complex, pivot tables are really handy. So select the entire spreadsheet to create a pivot table. You can do this by either clicking this corner in the upper left or Command A on a Mac or Control A on a PC. And then you'll go to the top menu and you'll go to Data, right? Data from your top menu, and go to Pivot Table. And when you do, you'll verify the parameters, which are all fine as they are, and you'll click Create. So if everybody goes and does that, I'm going to get my window down so I can access my menu here. I'm going to go ahead and delete these so they're out of the way. So to do this, I'll click here, select the whole thing, go to Data, and Pivot Table. Hit Create. So it starts my pivot table in a new sheet, right? So once you're there, you'll have, similar to your chart editor, you'll have a pivot table editor. And in your pivot table editor, you're going to want to go into rows and you're going to click Add. And you'll select one of the data types from the drop down. I recommend you can start with department, but you can really do whichever one you want. And you click Add to the columns and select gender. Let's try gender, right? Or something of the like. And if you have used the department content type under rows, you may see that your data probably needs some cleaning like this. Likely you will see something where there's, in this example, we have right here, Anderson and Anderson School of Management. or molecular farm and molecular and medical pharmacology. So we really should combine those things because these are referring to the same departments. This is why it's important to clean and standardize your data right before visualizing it. So click Add next to the values and select Gender and make sure it's a count A is selected under Summarize By. So in case you were wondering, the difference between them is that count only counts cells containing numbers, but count A counts all cells that aren't empty. So think of it as count anything. So I'm going to quickly go over to my sheet and try to do this with you all. Some rows, department, right? And this again, to columns, I'm going to add gender, and then values I'm going to add right, count A. Okay, so we have those things. Now, once we have that, we're going to select the insert chart icon again. And you'll have a stacked bar chart as a result. So here I'm going to use the ... because my screen is kind of squished. So Google has put it all under the second level. I can do insert chart. Oh, and I'm not getting this. Why is that? Is anyone else having an issue with this? Oh, I'm sorry. This is because I picked mail. 1 second. Let's go back. Let's do this again. Law of demos. All right. So I want to make sure that the whole pivot table is selected. Leave. So I'm going to do this. And then I can select. There we go. So I also have my grand total here because I've selected everything, but you can see it just depends on what you've selected, and that's how it will create a stacked bar chart for you. Is that clear? Any questions on that before we move into Tableau? Awesome. I'm glad you guys are enjoying. Okay, well, let's move into Tableau because if you think this is cool, Tableau's even cooler. So Tableau is an industry standard for data visualization, so it's really a good one to be familiar with. If you haven't had a chance to yet, go to Tableau Public, Google Tableau Public, or go to public.tableau.com, and you can sign up for a free account and enter your email to download the Tableau Public app. This may require a computer restart, so if it does prompt you to do that, you're welcome to just follow along with me. I'll give everybody a second to go ahead and do that. So when you create a free account, you can also do it down here. And your download should begin automatically, and then you'll need to install and restart your computer. So does anybody need a few more minutes to do that? I just want to check. If not, I'll move forward. Everybody's good? Okay. So if you are still installing, go ahead. If not, let's download this data set. So this link will take you, this bit.ly link, which is blocks. There we go, bit.ly, to shipwreck database. This will take you to a folder that will have a sheet that you can download, as well as a brief if you want to know a little bit about this New Jersey shipwreck database, which is very, very cool. Does anybody need the link to this? I can send it to you if you... Let's copy this and I'll put it in the chat. Okay. So you can go ahead and download that shipwreck database. That's what we're going to be using for our Tableau tutorial. And again, I've canned all of this on slides. I will try to navigate back and forth between Tableau, but I know that we're running low on time, so I may move kind of quickly through the slides, allow you guys to follow along with me via the slides, and let me know if you have any questions as we go. And if I have to jump into Tableau and do it, then we'll do that if we're running low on time. So you're going to start, once you have Tableau, the app should look something like this. And when you launch it, you should see a screen like this. So on the left, you can import many different file types, and you'll see that on the left-hand screen. And we're going to be using an Excel sheet, so you're going to want to use that one. But I also want to note that you have a great repository of tutorials and resources from Tableau Public, and they're over here on the right-hand side. I'll cover the basics today, but if you want to keep going, I recommend you explore these. They're really wonderful. And in addition, side note, for more resources, several colleagues of mine at UCLA have put together some additional guides through Read the Docs. Definitely check these out. They'll cover some of what I'm covering, but also other things as well, so good variation. So if you have multiple sheets of data that you want to work with, say if you're working with a relational database, for example, you can connect them within Tableau, which is why it's so powerful. Or for almost any data visualization tool, you're going to have to spend some time, though, formatting and labeling your data for the tool so it understands how to read it, right? Computers are not smart. Programs are not smart. We make them smart. So you have to train the tool and tell it exactly what you want it to do. When it inputs your data, it will try to best approximate what it thinks it is. But for example, year built, right, is obviously a date. It's not a text. And right now it's labeled as ABC, which is a text label. And you'll want to go and switch it to date so it understands that it's a date and it should be read as a date. So we're going to spend some time doing this when we use the bottom menu to create our own worksheet. So you can create your own worksheets down here at the bottom. So first and foremost, we'll show splitting a column. I'm going to actually go into my Tableau and get my data set input. So I have my shipwreck database, right? Open that. Take a second here. And there it is. So I have my full data set. And like I said, I have these labels at the top that I'm going to want to adjust for my data set so that Tableau understands what kind of data it's working with. So in terms of preparing your data, oftentimes you'll see two types of data within a single column. And I'm going to quickly switch back to my set here. So in order to read it, Tableau needs city and state to be separate. If we want it to work with the geographic, if we want it to work specifically with our geographic data, right? So you can edit by clicking down the arrow at the top of the right of the column and choosing split, and that will separate those things. So, for example, where built, let's separate that column. So, let my where built, right? Split, right? And now we have we're built 1 and we're built 2. So we want to rename these things so that we understand that this is the city and this is the state. We can also relabel it in terms of its data type. So rename, right? We can say where built city, and then rename where built state. Everybody got that? We can either delete or keep this original column just in case if we want to have it as a backup. And then we want to switch the type. So we click on this right here, and we want to tell it that it's a geographic role, and the geographic role is city. That way it can go out and it can find those Latin longs for us. And the same thing for we want to say state or province. Some of these have England, so it might have some difficulty with those, but for the most part, they're states, so that's all good. People following along with that? Does that work out for everybody? Okay. So, as I said, we should create 2 new columns and double click on the column title to rename it. And then next we'll relabel them. We relabeled them as geographic data. One is city and the other is state. So if you see some issues within your automatic split, you can create a custom split instead. So for example, between first name and last name, you can just use a space as a split if that needs to be, or New York, comma, New York, right? That those, you don't want it to split at the space, but at the comma. So you have to sort of pay attention when you're working with custom split, and you can enter in a character that you wish to use as the separator and choose it if you want it to split into one or multiple columns. So let's take a few minutes now to adjust the following columns in your data table. I'm going to take my Tableau public here and I'm going to drag it off screen so you can't see it, but I'm going to make the adjustments along with you. That way you can be looking at the table as you go through. So we'll first adjust the year built. So everybody go in and change that. Quickly to show you. So we're going to change that year built. Right? We want to change it to a date. So clicking here, change that to date. I'm just going to go back and forth a little bit so that you can see what I'm doing, and then I'll move it off screen so it's not so confusing. So where built, we want to do a custom split right between city and state. We did that. Date lost, we want to acknowledge that as a date. So when our data sheet is long like this, we can just scroll using the bar at the bottom. So we want to switch date lost to date. Now see how that's all reading as a date now? We like that, that's good. So for length, we want to switch that to number decimal. Go to, keep scrolling down. So these are all labeled as numbers, that's okay for now. Let's see if I can find it. There's length. So we want to switch that to number decimal, because we understand that the length of a ship can be longer, right, than a whole number. It obviously has a decimal. The beam in the same way, and the draft in the same way. All right, so let's transform them. So number decimal rather than number whole, right? You able to follow along? Everybody getting that? Any questions? Okay, so then we have gross and net tonnage. So again, that's also going to switch to be a number decimal. Home hailing port, this we're going to custom split between a city and state. So we do that by going to the drop down and custom split. So this gives us the option of any of these separators being a way to separate. So we like that. Let's say okay. Let's do an automatic split. There we go. So we have departure port. We also need to do that for home hailing port. Okay. And so when we do that, we can relabel them, right? And we want to make sure that they're labeled correctly. So these are cities. So I'm just doing this quickly, but in theory, we'd go through and we make sure all these commas are dealt with. State. That this one's identified. And same here. You're all getting the hang of this now, right? So should I want to be in here? Check out the home. City. State. So our final things that we want to switch are crew. We want to make a whole number because you can't have a partial crew member, right? So this is when we talked about data types earlier and different types of data. This is an example of something with an absolute zero where you can only have whole numbers. So crew, lives lost, you can only lose a whole life. Ship value can be decimal and cargo value, but can be decimal. So let's quickly do those.
I have a question real quick.
Sure.
So why do we have to go in and change like the data type to number whole or number decimal when we can probably assume that the numbers inputted in terms of like lives lost are already whole? Like why do we have to go in and redefine it?
Right. So in this case, if you see here crew number, it actually, the problem is that Tableau wasn't smart enough to relabel this as whole. So you have to tell it, that it's a whole number. You have to tell it it's a number. And if you're doing that, you have to tell it what kind of number it is. Right. So if this comes in and it already identifies it as a number, then it may work out just fine. But it depends on the kinds of visualizations that you're attempting to do. And that's when whole versus decimal can matter. So it just depends on sort of what the goal is of your, and the data, the graph type you're choosing to make. But ultimately, it's because when it first comes in, it's not recognizing these things as, it's recognizing them right now as a string, which is text, as opposed to a number. So that's the big thing. The great question. And we'll just do quickly ships value and cargo. Ships value. Here we go. Okay. So all of those things should be switched over now. So once you've prepared your data, now you can start working with your data. So the interface is you're going to open a worksheet. And once you open a worksheet, so this is, you always have your data source that you can go back to, which is this, but you're going to click sheet 1, and that'll allow you to see your data. So now you have your visualization interface, and this is a WYSIWYG interface. So WYSIWYG stands for what you see is what you get. Essentially, it means it's a drag and drop interface. So the difference between dimensions and measures, as we can tend to see over here, right now it's in, let's see, here we go. So the difference between dimensions and measures, which you'll tend to see this data side split into, right now it's in, let's see if I can just, we'll get into that in a minute. But anyway, dimensions and measures, you'll often see in many different types of programs. And dimensions are fields that are used to slice and describe data records. For example, names, dates, IDs, geographic info. While measures are the value fields of those records that will be aggregated. So things like whatever's going to be summed or averaged to arrive at some final results. So the show, and then finally the show me tool here on the right is a widget that can help guide you on what you need to make for a certain type of visualization. So for example, if I come in and I say, I think I want to make a really compelling bar chart or stack chart, what it tells me is that I need 2 dimensions and 1 measures. So I know from my list over here that I have to make sure that I'm choosing a dimension versus a measure. So I'm going to hop back to my sheet here. This will be a little clearer as we move forward. So we're going to start by dragging and dropping the items within the dimensions and measures to the left, to the column and rows that are at the top to get to know your data a little bit better. And then the Show Me menu on the right will help guide you about what visualizations might be best suited for the data you've selected. So for example, if you choose from over here on the left, if you bring over year to the column and you bring over departure port, the city specifically, to the row, we can use the Gantt chart to see popular ports and heavy departure years. Or we could note that the absence or outlier in our data. So for example, around 1800s, when we do this, around 1800s, we see there's actually very little data here, and you might wonder why that might be. And so we might do some more research based on that absence, or we might note, wow, around 1860s, between the 1860s and 1880s, there was a lot of traffic, particularly coming out of Boston, right? So we may want to look at that and focus on that data for our research question. So this method is the basis for data viz tools out of Stanford, one particularly called Breve, Breve, so you can look that up. They also have another tool called Palladio that has a great set of mapping features and can also deal with image data. The only drawback with Palladio is that it doesn't allow for a dynamic export of your visualizations, which Tableau does, and we'll get to that in a little bit. I know we're running low on time, so I'm going to just stick to my slides now and move forward. But if you have any questions, please stop me and we can try to jump in together. So if we do another one, we can create a new sheet and add cause of loss to your column section. So again, you're pulling from that left data column, and you're going to bring over cause of loss and drag it and drop it in the columns area. And then you're going to add it again. So you're dragging the exact same thing, but this time you're going to drag it to rows, and you're going to change it to from a measure to a count. And the way that you do that is when you hover over these things, you can actually, there should be a drop down that shows up, and you can click on that arrow and you're going to go down from measure to count. Now when you do that, likely you'll first be given a really long bar chart, which is not really compelling or useful. And this is where the Show Me tool can be really helpful. It will highlight other chart types that can fit the way that you format it, that can fit to the way that you formatted your data. So in this case, switching to a bubble chart makes it really easy for us to see what are the top causes of loss within the data set. Right, so if we go back to our design kind of fundamentals that we talked about at the beginning of the workshop, the reason why you're visualizing becomes increasingly important when you're looking at your data. And this is an example of where a design choice can make a big difference. Size here instantly tells us size and shape, right? As opposed to a bar chart. If we create a bubble chart, we can instantly see the top reasons for why ships were lost. And while the biggest is that they were stranded, we can also see something like, wow, a lot of them burned. So what was the degree of fire safety on these vessels at particular times? And maybe that's worth looking into. So this is a way that we can get to know our data really quickly by using a data visualization. We can also do comparisons. So let's create, again, a new sheet. So at the bottom of your Tableau, let me quickly just show you here. You have these sheets down at the bottom. So you can create a new worksheet, a new dashboard, which we'll talk about in a minute, or a new story. I believe it's a story. Yeah, new story. So each one of these things you want to create a new worksheet, and I'll show you why that is in a minute. But so when you're dragging and dropping things over, just keep creating new spreadsheets or new sheets down at the bottom, because we can put them all together using the dashboard feature. So I'll show that to you in just a second. So in this chart, we can create a comparison of the lives lost to ships lost over time. So if you drag your year to the column section again, right? We want that to be the thing that we're building across the horizontal. And then you drag both lost and lives lost to the rows. So you're dragging both of those to the same area. And you're going to switch the measure to select count again, because we're counting how many lives were lost and we're counting how many ships were lost over time. And we can do that side-by-side comparison, or we can do a dual timeline, like you're seeing here, which is a chart that layers the numbers and see them compared directly over time. And then finally, we'll do one last chart. So this is to show you a little bit of mapping. I recommend that, though, that you take a look for workshops with Albert Ketchupum or Yo Kawano in our workshop portal if you're interested in working with location data specifically. But we're just going to dip our toe in the water here. Bringing vessel types to column and where built to rows. And if we do that, we're going to switch the type to measure and select count, and then use the show me feature to select maps. Now I know this is a little confusing here in this visualization, but if you follow along with that, if you bring vessel type to columns and where built, the where built to rows, and switch the vessel type to measure and select count, and then use the show me feature to select maps, Tableau will automatically generate the lat and longitude for you. And that's a really big deal because, again, a lot of GIS tools, that's part of their paid service. So in Tableau Public, you can get it for free. And you want to exclude these 33 unknowns for now because we only want to look at location data that we know. And excluding these unknowns will give our visualization more contrast, and obviously we'll look into that. Those 33 unknowns are examples in our data of things that we might want to look into. But for now, we want to just get a sense of where these things were built. So when we do that, you'll see we'll have a higher contrast map. But what we can do is we can then filter our other graphs based on this map if we use the dashboard feature. So the dashboard feature, again, I'm going to slide into Tableau for a second here just to show you where the dashboard feature is. The dashboard feature is this second little thing down here. And once you've created different sheets, you'll see they show up here in your dashboard menu on the left of things that you can drag over. Right now, I don't have anything in these sheets, so it's not going to look very dynamic. But if you followed along and created those charts like I did there, you'll be able to drag and drop them over, and they kind of snap into view, so you can pull them against each other, and they should readjust nicely. And using this little thing that looks like a funnel, you can connect all of these things to one another. So you use the center icon at the bottom of the bar to add the dashboard, and then you drag over your sheets from the left into the space on the right. Adjust the size in the left menu to automatic, and the graphs will automatically make room for one another as you drag them over. So see this thing over here? If you adjust size and make it automatic, they'll naturally kind of format into space with one another nicely. And labeling your sheets will help keep things clear. So double click on their tab at the bottom and rename them. So in each one of these, you can double click and you can rename these so they're very, very clear on what each graph is. And like I said, you can turn on the filter for all of your data visualizations within the dashboard, and this allows you to filter all your data visualizations by whatever data you select within one of the visualizations. So if I wanted to look at California, right, the data related to California across all these data sheets, when I do that, when I click on this, all of these charts are filtered by that piece of data. Then I can click it again and unselect it. And I can do that for if I wanted to look at the stranded ships, right? And that will filter both the map, the comparative chart, and the Gantt chart by all the stranded data types. So pretty cool and powerful, especially when you're trying to create a narrative with your data. And for those of you who are wondering, I'm seeing in the chat, I know we're coming up on the end of our time together, and I will be wrapping this up very quickly. But the recording will be on the IDRE, IDRE YouTube channel. So take a look out for that. I'll also send a follow-up email if you've signed in using that spreadsheet in the very beginning. I should have your email from that. If not, you can always email me and let me know, and I'm happy to send you the recording. So great question. Thank you for that. And once you've finished your work, you can export and embed dynamic visualizations into your web pages and such. So another great aspect to Tableau is that it exports really easily and embeds really easily, and you can get dynamic visualization embeds, which are so great for websites, right? Everybody likes a visualization that they can actually interact with themselves, and that's what Tableau Public allows you to do. So the way that you do that is you go to File and Save to Tableau Public As. So File, Tableau Public As, and you can save your sheets, sheets, your worksheet, your dashboard, or your story, and you'll label them and you'll hit save. And then what you'll do is in a browser window, you will need to log into the Tableau Public site to see your visualization. So again, you'll have to go to this Tableau Public page and log in. I'm logged in here, but once you do, you can go to your activity and, oh, it's making me log in again. Anyway, you can log in to your Tableau Public page. You can see it here as an example. Sorry for that. You'll scroll down. It has all your data sheets there for you that you've saved out. And if you go down to the bottom of those windows and click this little connected icon, you'll get an embed code or a link, and you can use either one of those to share your data. I will point out, though, that once you have saved your data out in Tableau Public, it is public. You've made your data public. So please only do this if you are okay with making your data public. If you're not, you can use it on your desktop, totally fine. You can save it, totally fine. But when you save it out to Tableau Public, then it becomes public data. So keep that in mind. There is a Tableau desktop version, and you can look into getting a license through Software Central for that. So if you do want to keep your data and all of that private, you can use that. But Tableau Public, if you're working with data and you're okay with it being public, is great. So with that, I will leave it there. Thank you so much for taking the time with me today to learn some more about intro to visualization, data visualization. I hope this was all useful to you. I'm actually going to stop sharing so that you can see me. So I can see you all. So thank you again for that. Actually, I'll share one more time just to let you know in case you're interested in contacting me, or if you would take our Data Viz Exit Survey. 60 seconds would be really helpful. It helps us structure these workshops and see how useful they are to you. Like I said, we're recording this one. They'll be available on the IDRE YouTube, and we're trying to get a better sense of how to do this remotely since we all can't be together in a classroom as usual. But thank you all again. If you have any questions, please let me know. Feel free to email. I want to be respectful of your time, so I won't keep you after. But I will stick around if anyone has questions. I'll turn off the recording. And again, happy to hear from you via email. Thank you so much.